Hey everybody, this is Brian. Sorry for being late.
Hi, Brian. Just ping Ram. Um, haven't heard back. Maybe we can start and hopefully he joins. We were reviewing some opens that Brian brought after he has reviewed the document. And I think one big one that we are revisiting are the error messages. Is there any open that we can discuss before jumping where we were?
Yeah, let me. Sorry, had a bit of a run over, and I'm kind of getting caught up. The Sorry, yeah, the error was the big one. I think. Let me pull the document back up here and um, share from my computer. One second. Can you guys see my? I think I'm sharing the right one. It's not showing me the preview. Can you guys see the share of the doc?
It shows gray on my end.
Okay, let me. What is? Let me retry that. I don't know what's wrong. Okay, all right. Well, I'll just skip the share. Everybody can kind of follow along with the doc, I guess. Let's see. I haven't, so, okay, I've unfortunately had some bunch of back-to-back travel recently, so I haven't made any progress on the link control section so much. I mean, I had, what I had before, which is mostly on, uh, some of the other sections I was pulling into link control, but the existing link control sections I haven't done a lot with yet. Let me go through the actual opens though, that we had from previously. So the big one that you mentioned earlier was the error code stuff. I had added some brief text, removing crossing out some of the error behaviors that I had question marks and opens there, and just said it's user defined. Um, let's see where the opens are. Oh yeah, okay. So on the back to timing, um, I haven't seen any document that actually has the timing in it. Rom sent me an email on, or put a note in there about the specification, in that section, but that section was pretty much the one I think I showed on the call, where it shows all of the signals. It talks a little bit about the timing, which is pretty much the same wording as we had originally in our document, which was, let me see, oh wait, no, I actually responded to Rom's comment. It said, talks about the data line being, what it's aligned to the rising edge of the clock or whatever it is. But it doesn't talk about frame. The original BOW spec doesn't talk about the frame. It doesn't, like, what the frame signal does. It doesn't talk about the timing of the transmit and receive frame signal, etc. And so again, I added language to that, to our document, because it seemed like something important to document, and I made a guess. So I think it would be good if everybody takes a look and see if that makes sense, or if we have insight into what we think was implied by the BOW spec, or if there's another version of the BOW spec that actually has a timing diagram in it. That would be helpful. And then if we need to, we can, I can whip up a quick timing diagram. But I don't know if it's needed or not. And I'm not sure if there's anything that I assumed in my assumptions here that are going to cause anybody heartache. But basically, I'm just saying, basically all I say is the frame has the same alignment as the data clock. And that I talk a little bit about we talk in general about the frame behavior, but I think I had another sentence there. So that's just generally, any detail there is an open, like, what do we have? Is the text that we have currently sufficient? And do we need any kind of diagramming to go along with it? I think is the open.
Yeah, I would agree that the diagram will definitely help because a picture talks 1,000 words. So that definitely helps. But that said, I think if I vaguely recall sometime back, I think the phi group, they wanted to keep all the phi specification in one place. There is a document that I forwarded the link for. But
Yeah,
I don't
that doesn't have that
access.
information in it, Ron. It
Right.
doesn't have that.
And I don't have access to their latest documentation because they have a latest draft as well that they're working on for 2.0 and 2.1. I don't know if they've made any amendments there because I couldn't find the draft spec as they update every week. So that I don't have access to that spec, so I couldn't find it. But I think if a timing diagram is needed, probably a better place to put that would be into the other spec because it talks about the sideband physical signaling requirement. And since they're also using the sideband slices for other activities, maybe it would be a good place to define all the timing requirements and the diagram in there.
Is anybody that's in this group also in that group?
Question to clarify the two options. The other document is bow phi. Is that right?
Yeah, it's just the normal bow specification. And so they have a sideband subsection in the bow. It's like at the very end of the bow specification, and it lists these signals. But that's pretty much all it does. Well, I mean, it does more than that. I guess it gives some electrical stuff too. But it's very terse compared to the rest of the bow spec.
Yeah, and I also remember what Rom said, that in one version or the earlier release, there was nothing about the sideband phi, and then they added that. Okay, thank you. I think that the timing seems something that belongs to the phi, in my opinion. but I'm open.
So they, like I said, they talk about the timing very briefly. Like they talk about the raising edge, which is the same language we kind of had, but they don't give a timing diagram and they don't cover all of the signals. And so that's, or well, it's not even that necessarily. Like we're actually defining the behavior of what frame does and stuff like that. And I'm not entirely sure that we should even be defining that. Because I'm not sure whether that's really in our protocol domain. It sounds like something, it sounds like to me something that they should be defining and we should be sitting on top of, right? But there should be more of the protocol in the bow spec for this sideband if they're going to define specific signals like that. But that said, they may have a different opinion about like what considers, what's considered the protocol and things like that.
I'm aligned with you. That makes sense.
So, do we have a method of communicating this to them? I don't know anybody in that group, I guess. Not anymore.
I believe Elad is running the fight team. Is that right? And I think that's Wednesday mornings. And
Okay, so maybe just an email to Elad.
yes, we can. I can try. Paul, can you share again Elad's email here for us?
Yeah, I'd be happy to. Let me dig it up.
Thank you.
Yeah, I think I have it too somewhere.
Okay. So if you could send an email to Elad and CC the link layer distribution list, maybe that would be good.
Okay, yeah. Let me do that, see if we can get some movement there and figure out what the intent is. Okay, so the other thing here, like I said earlier, next open was error. Again, I removed, like I said, everything on the sideband protocol side, except for the fact that there's an error bit and it's user defined, or at least the behavior is user defined. I think I kind of want to add a little bit more text there saying, I'd like to give it us a little bit of flexibility in like saying, all right, these bits are reserved. And then, in the future spec, if we decide to actually do something with that, then we have the capability. But we'll explicitly say these bits are, user defined and you guys can do whatever you want with them. And if anybody has a problem with that, please let me know.
Brian, are you sharing your screen or?
No, it kept coming up blank and I don't know why. So let me try again. I don't know what is going on. It immediately pauses. I probably have to do a Zoom restart. Yeah. Okay. So I don't.
Let me try at my end. I think it's good to have the. Does it show?
Yes.
Okay. So I think I apologize. I'm on my laptop and it's tiny screen. So we're talking about the error and
yeah, so there's two error opens, I think, right now. The one was in sideband protocol, right? And that's the error. That's what we talked about last time and what we need to, and like I said, I understand the, not wanting to get in the rabbit hole, right? So again, I just want to clarify. I just want to first clarify: does anybody have a problem with that bit being there?
Oh, the having an error command.
Having an error command, right? Whether it's defined or not, whether the behavior is defined or not.
We thought we wouldn't need it. I think that's how we chose that. Okay, so we don't need it.
That's what I disagreed with, I think, last time.
Yes.
So there was, whether we needed it or not, I think there still felt like there were cases where it would be handy. And at least my logic here is that okay, if you don't want to add another command bit, then there's no, okay, I see there's a trade-off there, even if it's needed. But we already have the command bit, so why not just define it? So that was my logic there. And I am okay making these user defined if we don't want to go down the rabbit hole of doing a whole state machine and chart of behaviors and things like that.
And let's remind us again why I remember you said the error that we generate at the command level is a bit at the lower level than when it is a message.
Correct. And I think my biggest use case for this really, it would be debug. So if there is a link level hardware or signaling issue on sideband, I think having a command level thing like this that doesn't get trashed by ECC and all sorts of things like that, or trashed by errors or have to go through ECC or whatever, could be helpful for people. And again, maybe other people would just do a custom a custom command for that or something like that. But I think having an error would be a more standardized way of packing that data in there for debug.
So I mean, my opinion on this is I'm okay with that because I mean, I had that and I have this in my original implementation. So, and it was put in there exactly for the same reason that you just mentioned. But if we are going to make it as a optional field or an optional code, then probably we may also have to provide guidance on how two systems, one that supports this and one that does not, would interoperate.
Well, I don't think it's optional. I mean, you have to know the error code. You have to know there's an error command, right? And I think you have to be able to at least throw away the packets, possibly signal to your local system that one happened. I think the optional side is what you do with the data in the error packet. And so, but I think that at that point it becomes implementation specific, and I think we can say that.
Yeah, I agree that at least at the acceptance and generation of the command, it should not be optional. But the behavior implementation is implementation dependent.
And I can, if there's more text that's needed there, like I said, I can add that. So it sounds like we're broadly in agreement then.
So where's the text that exists today that describes this?
It's hold on, just let me double check. I think you just scroll down, hell yeah. I think it's I crossed out the vast majority of it. Here you go. Error command can be used to signal sideband protocol error to the partner chiplet. Implementation of the error and the error response. Implementation interpretation of the error and the response is implementation dependent. And like I said, I do want to add a little bit of text there, or a bit field there. Actually, well, I guess that's an open I haven't put in here, but a bit field there for saying, okay, these bits are reserved and these are not. But on that note, I think for all of these commands, a bit field diagram showing what's what might make, or no, maybe not a bit, like a table for each command might make sense. But I haven't put enough thought into that to say whether it's actually needed with the existing text or not.
So are you saying that the definition of the message field changes when it's an error command? There's no longer address and data?
No. I'm just saying, okay, so again, it's not here anymore, but or at least I've crossed out things there. But you can see, you know, address field may be used depending on the type of error and things like that. I think if you're going to give error, my inclination would be if you give an error, then you're basically repeating back the address of the transaction that caused the error. But I don't want to necessarily say that at this point. So I would just put those in reserved.
So error would be like a write message. Or has the write message format.
Yeah,
But
sure.
can be defined.
Yeah. It would be a write message format. It would have data as well.
So it's a write message format, but depending on the implementation, it can have maybe more primitive behavior, that there is some hard-coded, very basic error that system is just not responding if even the write doesn't work.
Again, you're fully independent. I mean, you know, in some systems, again, you know, just so we don't get down that rabbit hole and just define the whole state machine, you know, I'm fine with that, making the implementation dependent. And so we just define as little as possible there, saying, like you said, we should probably say it's a write command because it does have data, and that, you know, a lot of the existing fields would be maybe I'll put together a proposal. I don't want to just spitball it, but I'll put together what the fields are in the proposal. But it'll look, like you said, just like a write command. Just you can put your custom data in the data part or something.
So it will be superset or that of what we kind of put in today, that it's a type of message. So what we had was that error is a type of message. Let me just go and show
So
that.
I don't think this precludes that, because like I said, again, my goal here is really debug, because at the lowest level, right?
But I agree
If we
with
were
you.
defining errors, and the way I started defining errors earlier was to kind of break these things up a little bit, where the lowest link level errors like secdead and stuff like that would be covered by this piece, and that the higher level errors that are in the link control would be handled by the link control errors. And again, since we're not defining either one, you know, you can put them in both places if you want right now, or you can put them wherever you want since it's implementation fine. But the piece that's needed there, I think we still need more text around that error message for the link control.
Yes.
As well.
So what I was trying to say is that this would be at the little higher level, as you said, and I'm not quite see anything that can get broken by introducing the error command. It allow us to have more primitive error message, or error signal rather, and the error message format could follow maybe this. And if that would be helpful and simplify and make compatibility easier between the two implementation. So
sorry, can you I kind of broke you.
So this is what I'm thinking, that the error command is a write, and it can have some hard-coded write error messages in it, and then when it is acting as a write, it can have this format. When it is want to write to an error message to a specific place, it follows this. So we don't need to redefine all the error behavior in the implementation, but we allow the error command to, actually, this would be a write command. So we can send a write command error message with a write command, and then we have error command that is just purely link layer. Yeah. Okay.
Yes.
Now I think
Yes.
that
There's two different
So
kinds of
I
errors.
just add just one more comment. Maybe we should also add another implementation note saying that we should limit the number of errors we send. The reason being, since this is a primitive error type mainly triggered by, say, a packet drop because of an ACC error, there could be a chance that the sideband link is really bad, and we may end up in an infinite loop where both sides are sending error messages, and because the error message is getting dropped, it is generating another error message. So we should probably also add an implementation note on a possibility of an error message storm that could happen if things are left unchecked.
So are you talking about like an application note, or are you talking about a actual protocol thing limiting the number of error messages?
It would, since this is at a protocol level, maybe a protocol level node. I mean, I don't know how you want to call it. It could be an application node, it could be an implementation node as well. But we need to highlight the fact that if both sides see CC errors and they start generating error message command type to respond to the other side, there could be a possibility that both sides are sending error messages back and forth, and the error message itself is getting dropped because of an ACC error, and that in turn generates another error message from the other side. So this would go on indefinitely in case of a bad sideband channel.
Okay. Yeah, I'll make a note of that.
So going along
Okay,
with, I'm
okay,
sorry,
go ahead, Paul.
I was just going to ask, so the address really is an address that this write is happening to? I'm still trying to understand the
There's
protocol.
there's two different errors here, right? And so again, for the protocol error, I think all of those things are open at the moment. For this one, this is an error message. Now, again, Ron, correct me if I'm wrong, that gets written to the other side's register, right?
That is correct. The one that is communicated through the partner message register, that would be to the partner's register space. But in the protocol level error that you just defined, the new error field of 111, for that, at least in my implementation, when that command is received, um, I don't look at the address, but I internally log a status and interrupt the processor on that side. So that's how I implemented it originally. But yeah, I mean, I believe for the command type that is error, the address fields probably are don't care.
I
So
think, well,
go ahead,
sorry.
Brian. No, go ahead.
Well, I was just going to comment on that one last thing. I think the address field of the error command is useful for you if you're trying to respond to a specific transaction. So if someone does a transaction has a let's see, there's a couple of different errors in the ones I listed in that section that I crossed out, where knowing the address of the command in which you are considering an error would then be useful. Like if you're getting a mismatch between returns and things like that, then having the address for that given transaction would be helpful in a debug scenario. But again, we don't need to necessarily define that. We can say, you know, address may optionally be used as the address of the errored transaction, or something like something again that's implementation specific. Really, it just gets logged, and you use that in your debug or in your error response upstream.
I'm fine with that. I just think we need to say that you should not. I mean, we need to be clear that if for this message you don't use the address as you normally would for all the other messages. Right. I mean, this is a special message, right? We're saying
this is a
that
special message anyway. Yes.
Yeah. And so I just think we need to document that. I'm happy with what you're saying, right? It's just that's not clear to anybody who's doing this, right? That's what
yes, absolutely. Yeah. No, I've already added a to do for this. So I need to add because I was saying we need to say what the packet format is and which bits are reserved. So
Sure. Yeah, no, that's good. Okay.
Same with address and everything.
Okay. And so Ram, in your case, what register does this message get written to? Right? You're going to pass some information off to firmware, which is fine. I'm happy with that. But there's got to be a place that firmware goes to look for this thing, right? So there must be an extra register now in your implementation that is the quote unquote error destination register. Is that right?
Right. So in my implementation, when I receive an error command, I would log certain fields of that register. So for my debug purposes, I just wanted to log certain user-defined fields, and that would be logged into an internal register that belongs to the sideband config and status, and log an interrupt to the firmware, and then the interrupt status is also within the config and status fields. So it's implemented more like an ISR that goes and interrupts the processor.
Yeah, that makes perfect sense to me. That's kind of how I was envisioning it. I just think we need to be clear in the spec. You know, we've made this new thing up. The address field no longer means what it used to mean, but it does mean that you have to write this message to a special place, right? That doesn't
Right.
exist.
So that is handled by the hardware itself. So the hardware that receives the sideband command and does the ECC check and does the command check. So when the command is of error type, I don't really write that to a specific location, because if you recall, right, I think your implementation is completely firmware interpreted. But what I had implemented is completely hardware interpreted. So the hardware interprets that command as an error command and takes a different action compared to what it would normally take if it is a read or a write.
Right, and I'm happy with that. Again, we just need to state what we expect to have happen for these messages, right? Because it's different than all the other messages, and it's not just the address that's different. It's like, because there is no address now, we have to like say that, yeah, the destination for this thing is this special place now that again didn't exist before.
Correct. So I mean, if you want a very generic implementation, then probably we should also define an error register where we can go and capture everything that we have received. So I don't know if you want to log the entire frame and then do implementation specific implementation for that. If you have to do that, then yeah, we'll have to store that when the command type is of error, we may want to store a bunch of those frame fields into some register. So maybe we can, yeah, if we have to do it that way, then we'll have to call that as a separate error register along with the partner messaging register. So so the three highlighted registers that that's currently being shown on the screen, we'll probably need a fourth one to say bow sideband error status or something like that. Or there is an error code already there. Okay, I missed that. So yeah, so that's where you will log contents of your command
Well, that error
that you
code's for
received as error.
that error code's for something else. Right? That's our errors, right? That's our local errors, right? This message is errors from the remote partner. So those are different things. No?
So I thought this error code was the error that we received. right? Not for the error that on the local that we detect on the local side.
Can we go find the definition of this register? Helia in this spec?
Yeah. Yeah.
It's just above there, table 8,
Error
right?
code register.
So this doesn't look to me like
Oh,
you know,
so this is just the local side. Okay, then we'll probably need like something like a partner error code. An additional register is needed if we want to go down the path of interpreting through software. So if software has to interpret what was received as an error command, then we will definitely need another register where the error command can go in, and then the part software can come and read it out.
well, do you think it's possible for hardware to handle these error conditions? I mean, I'm asking, you know, whether it's necessary for software to get involved. I mean, I certainly think it is, but again, I'm new to this, so
Right. So in my case, it was more like this was only a handful of errors that I had to handle. So one is the ECC error. Say the packet got dropped because of an ECC. And then I also overloaded the same field for slave errors on the other side. So say, for example, you requested a sidebound message to a non-existing register, and that resulted in a slave error or a bus access error on the other side. That would also come back as an error message. And especially for a read command, the other side is already waiting for the read data. So if it receives an error command instead of a read data response, then it would internally log that as an error and flag it to the software. So it was just a handful of things that I had to handle. So it was easier to do that in hardware rather than push it in software. That said, I think my original base spec has been evolved to a much complicated spec now. So yeah, I mean, if we want to keep all the flexibility in, then we will need some level of software interpretation.
So can I get a little more clarity on exactly what the behavior is here? So if you let's say your link controller encounters an error, you know, well, I guess it doesn't really matter what level because we're not defining that, but let's say something in from the actual link control side, right? Something in the state machine or something like that. And it would write that error to the local error code register and then also write that to the other links, the partner message register, right? Or is it only local?
Oh, yeah, I need to refresh my mind for that error code register. I'm not able to recall that because we have built everything into the partner messaging for communicating the error. So um, if I have to guess, and I don't know if that's the right guess, maybe Paul can correct me, but if I have to guess, then the side where the error was encountered, they would log that into the error code register on that side. And they also have to send a partner messaging register with that error code to the other side is what I think it would be.
Okay.
But I'm not sure what that error code is specifically used for. I don't recall that.
Okay. So we definitely need some sort of text there. You know, on what that behavior should be. So Ram, if you can give that a think and give us some sort of proposal that we can start fleshing out then. So, you know, regardless of whether how we're interpreting the codes, we need some sort of steps, I think.
Sure, and this is for the primitive error, or do you want something for the current error code?
This is for the link control side. Again, I mean, again, I don't mind if people pack the lower level ECC or whatnot in there too. But I think my concern, we're talking about partner message and link errors are higher level errors. So you could actually, I mean, you could have issues with your, you know, with the PHY or the state machine or whatever is going on in the main band. whatever you need to pack in, whatever you need to do, right, that would be written into a partner message error, right? I think those are the ones I think that are the concern in my.
So I think that if there is issue with the main band, but the sideband is operational, then we can pack them as write messages, what we have now. But if
Yeah, but you report
si-
those through the partner message register, right?
yes,
Okay, so I think that's, again, that whole behavior loop is my question. Like, what happens when you incur an error? Do you put it also in the local error code register here and you send a write message? And is that the only things you do, or is there more to that?
so I think that okay.
Are they the same thing between these two registers? That's another question.
I think I help us recognize that there are more errors, or there are more fundamental or basic errors that maybe the state machine doesn't work, that we can decode and kind of interpret what the error is. So the error will just continue to be sent and nothing would happen. So for those error, we define the error command. I'm still unclear what should be the format of that error command, and I think that is something that you and Ram are going to propose. For something that is
Yeah, both format and the overall protocol for what on how they should be reported.
yes, but if the sideband is operational, then there is some message that we want to get across. The message that we have today would be sufficient. Now I'm open if the error command could also specify and absorb that behavior. So then we will go ahead and basically scratch this error message, and that would be all that we have. So I will eliminate this row. So I leave it until we have some.
I think they both have merit, being able to report messages in the PMR and being able to report them at the link layer. Again, I think these are, again, if we were actually defining error responses here, again, which we're trying to avoid, but if we were doing that, I would assign the different types of errors to the two different categories, because I think they responded to at different levels potentially.
So yeah, okay, then that's fine. We can keep both and leave both to implementation.
Okay. So again, in terms of action items here, Ram, if you could just again give that a think on those two types of higher level registers that are doing this. I think we can. If you can give a general intent, I can craft some words around that we can review for next week. Does that make sense?
Okay, I can draft something up and send it to you on email.
Okay, sounds good. So while we're here, and I saw another note that I had put on earlier. I just wanted to get clarity real quick. Can we? Goodness gracious, where was that at? I just saw it fly by. Oh yeah, okay. Can we go up to table 10, register address map? I wanted to make sure that I'm clear on what's accessible here. So the way that we have the address map, in general, everybody can access everybody else's BOW sideband registers, right? Like you can potentially access another, how to say this, a partner could access the BOW sideband registers of the other partner. One chiplet can access the BOW sideband registers of the other chiplet and potentially initiate a transaction back to itself. Is that correct? Is that meant to be all of one unified address map like that, so you can actually do a loop back?
So the original intent was to be able to access your entire link addressing space. That includes your BOW link layer and your BOW file addressing.
Yeah, but I guess my question is, well, I guess two things. Number one, do we actually need that? And then number two, what would be the behavior of the situation I just described? Like, do we need to actually be able to support looping back like that? Like, what's the, I mean, I guess is it really just the configuration register we care about in terms of general addressing? If other people can access these registers, how do we prevent any kind of
So when you say other, so yeah, so I believe this was another implementation note that I had originally had. So this partner messaging scheme does not implement or does not take care of CSR coherency. Like say, for example,
right,
you're
okay.
writing to a partner, writing to a register in the partner. Those registers could also be written by the local processor of that partner. So this scheme does not address the CSR coherency problem. It is understood that whatever we are writing to the partner's register space, that register space is not mutable by the software running on the other side. And that's a software level responsibility.
Okay. All right. Yeah. Well, I mean, I figured that, but it's definitely a concern, right? Especially if you have any kind of errors in addressing or something that are coming across the link. But again, I guess I question, and again, it seems there's a lot of implicit rights here. Maybe I'm missing something here.
I'm with you, Brian. So I guess
Whoa.
maybe another note would be helpful here, that this shows the address map and the expected behavior is, as Ram said, there isn't a coherency. It's on software, on the local software, to make sure that that could potentially be corrupted.
Right.
Partner.
But I guess to another point, I guess that I understand the point of adding the addresses here, right? You're just making everything standardized. But do we actually want the partner to be able to write into the BOW sideband address
I'm
space?
guessing that
Because we can make them read only or something here, right? From the partner side, if that's a
so we talked a little bit about like having a completely brainless chiplet. So it seems maybe that piece could support that. I'm guessing.
okay.
Yeah.
No, okay. Yeah. Okay. Let me think about that for a second.
I can't imagine why you would want to do that.
Yeah, I just still don't see the point. Why would, if that was the case, I still don't understand how the partner would use one chiplet would use another chiplet's BOW sideband registers. If it was completely brainless, let's say you don't have like a microcontroller there or something like that, I think you would just not have these registers and you would have some sort of bus interface into the controller, which was actually a point I made to Ram earlier, but I've kind of digressed from it. But aside from that potential option, I still don't understand what the use case is for the access to these registers remotely. Seems like it would potentially it seems like it's another avenue for potential errors that would have to be debugged or cause lots of potential storms or whatever.
So like defining these types as read-only by partner would I think that.
That solves one potential error condition, but I guess before we even do that, the question is, why do we have them accessible at all?
Yeah, data and read data, I'm not sure, but configuration, I think maybe.
Okay, so on configuration, is there a use case where you need to be able to write into the configuration of the other side for error reporting or something, again, something implicit that I'm missing here? Let me, where was this? Right? Those registers are up in the definition for the control registers, the other section. Is there something that would make sense?
Sorry, Paul, I think you were saying something. Did I?
No, I was just going to say, I don't think so. I can't imagine why the partner would want to write into any of those three registers, not just to write in the read. Because they're really one conceptual register, right? They just happen to be broken into three pieces in my view of the world. There's more than 64 bits of data, so you got to break them in three pieces. But I can't imagine why the partner would want to write into any of those. So I'm happy with Brian's proposal of making them be read-only guys and making it be an error if the partner does try to write into those addresses. Like if there's an addressing error somewhere, Bob, and we mistakenly try to write into those, I think the best behavior is to block that from happening and emit an error.
Yeah, okay. So reading to the control register, I can see potential value of being able to read them remotely, because there is a, well, actually, there's a partner error bit. Oh, okay. No, I can see that. Okay, that's from the error protocol thing. Actually, that might be something we need to. Okay, sorry, I'm babbling. I can see the point of being able to read it remotely. So yeah, read only I think makes the most sense as policy, because you might want to be able to read the protocol version and you might be able to read the error statuses. Now, again, looking back at the configuration register, there is a partner error bit that's set in the control register. Is that something we want to set if we get an error command on the sideband protocol?
Yeah, you're bumping into the same kind of things I bumped into a long time ago, right? And I just don't understand the error architecture here, right? And you're asking the exact same questions that went through my mind like a year ago, right? I don't follow the intended usage for a lot of these bits. Like why are there a couple error bits in the configuration register when we have a local error code register? Right, first off.
Yeah.
Right. And then who is supposed to write those bits and what do they mean? Who's going to look, if the firmware writes them, who's going to read them?
Oh, which error are you error bit you're referring to?
Go to table 3. It's in the sideband control register, which table 3 might have been moved around. There it is right there.
Yeah. So I'm with you 100%, Brian. I just don't begin to understand what the intent was for those from an architectural perspective. Like why are they in this configuration register, right? This configuration register is the means by which we generate and receive messages. What do those error bits have to do with anything?
Yeah, you would. And this is something you would potentially be writing. So like, I guess those are reporting out. But do we need this? I hate to say this. Does there need to be another register here for status or something like that? Or maybe we should remove the status bits from this register and make them implementation specific. I don't know. No, that doesn't make sense. I don't know about that.
So it's the last two, the local error and then the partner error. And then did we just say that here we have a place for local error? So maybe we don't need it in the configuration anymore. And
I don't.
I'm fine by just making those in the configuration reserved to just clarify things and make things to clean up things, right? I probably maybe it started as a bit and then say maybe one bit is not enough. I'm guessing that that's how it evolved. So we can, now that we are defining a more robust error behavior, we can clean up the other bits and pieces of error messaging and signaling. Sorry, Brian, you were saying something.
I don't mind. I don't think it's an issue having error bits at that level. Again, because I was saying that, I think from an error partitioning point of view, it's different errors. So having bits that you can read from the sideband configuration that show an error happened, I think is fine. I think that the question in my mind is whether those need to be part of the config register or whether they're in either potentially other register or a future defined register. Because they seem like they're read-only bits. Same with this. I guess there's a question here about sideband protocol version. Like what happens if are you supposed to write that every time you issue a transaction, or are those read-only versions, read-only bits in the config register? Right, Ram just chatted. Ram, can you hear? Did you have to drop?
Yeah. Oh yeah, we are at the time.
So I can
I'm with you.
I'll add more. I'll add more to open here. I
Yeah.
think this is something to think about. Whether, again, I think there's three things I think we mentioned. Number one, we just want to make these read only, or potentially just not even accessible. But read only would be the first proposal. The other question is, other set of questions, I guess, really, depending on how you want to break it down, would be do we need to reevaluate what the configuration register looks like, whether that means more reserved bits or a better definition about what those bits do.
Yeah, I think now I clearly see what you're saying, that we are reporting status in the config. That is very confusing. What we could do is that remove those 2 bits from the config that we have at the top, and then have specific addresses, and that those could serve as status, right? It will be local error code and then partner error code, and then they have very specific address, which will be error status. One possible implementation. We can come to that next time.
Yeah.
Okay. Thank you, everyone.
Thank you.
Take care. Bye-bye.